In this problem, we're looking at, it says a farmer plants apple trees in a square pattern. And then in order to protect the apple trees from the wind, he plants conifer trees all around them. Here you see a diagram of the situation for the 1 through 4 rows of apple trees. So this one has 1 row of apple trees, just got 1 apple tree, and he would plant this many conifer trees around it. In this instance, it has 2 rows of apple trees, 1, 2, and then it has this many conifer trees around it. Here it's 3 rows, and then 4 rows. Okay, so first what we're going to do is just fill in a table, and then we're going to answer some questions based on this table. So, if the rows of apple trees is 1, then we have 1 apple tree. If the rows of apple trees is 2, we have 1, 2, 3, 4 apple trees. So we'll just put a 4 in that box. If it's 3 rows, we have 3, 6, 9 apple trees. If it's 4 rows, we have 4, 8, 12, 16 apple trees. And then the idea is, can we find a pattern that would help us answer these 3? So before we do that, let's move on and just count the conifer trees, and then we'll look at patterns after that. Okay, so the conifer trees, there's 1, 2, 3, 4, 5, 6, 7, 8. So 8 for the first one. Alright, and I don't want to count every single one. Looks like there's 5 on this side. There's 5 on this side, so that's 10, and then there's 1, 2, 3 in the middle. 1, 2, 3 in the middle, so 10 plus 3 is 16. Okay, let's look at this one. Looks like there are 1, 2, 3, 4, 5, 6, 7, and 7. So that's 14, and then there's 5 in the middle, 5 in the middle. So 14 plus 10 is 24. And then for the fourth, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9 on this side, so 18. And then 7 and 7. So 18 plus 14, that would be 32. Okay, so the idea is, can we find a pattern here that will tell us what the fifth one is, what the 99th, so if they had 99 rows of apple trees, and then n, we're just going to generalize it. So in general, n can be any number, n can be like 5,000, n can be 26, whatever. We'll find out an equation. We'll figure out what that equation is. Okay, so the first one, it looks like, I'm just going to write in the differences. Looks like this one goes up by 3. This one goes up by 5. This one goes up by 7. So the next one's probably going to go up by 9. So 16 plus 9 is 25. Now this is a great way to look at a pattern if you just want to find the next couple terms. But the problem is, if I want to find the 99th term, I don't want to find 6, 7, 8, 9, all the way up to 99. It's just going to be way too much work. So let's try to be a little more clever and figure out a better way to do it. And the one thing I notice is if we take 1 times 1, that's 1. If we take 2 times 2, that's 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So this one, if it's 99 rows, it'll be 99 times 99. And the way we write that quickly is just 99 squared. So if you're multiplying something by itself, it's just to the second power. So if it's n, the equation we could come up with is whatever this number is times itself, so n times n, or we'd write it as n squared. Either one of these is correct. You're probably going to see it most often written like that. Okay, so let's look at this one. This pattern is also pretty nice. From 8 to 16, that's 8. From 16 to 24, that's 8. From 24 to 32, that's 8. So it's constant. That's good. So this is going to be 8. So 32 plus 8 is 40. And once again, we don't want to go find term 6, 7, 8, 9, 10, all the way up to 99. We want to find a quick, easy equation to get us the number of conifer trees. So what I noticed was if we take 1 times 8, we get 8. We take 2 times 8, we get 16. We take 3 times 8, we get 24. 4 times 8 is 32. 5 times 8 is 40. So this one is going to be 99 times 8, which is 792. Okay, and then for the n, for any term, we're just going to take this number n times 8, so 8 times n, or 8n. So if we wanted to find out what if he had 15 rows of apple trees, we just do 8 times 15, and that would give us the answer. So that's the idea behind finding these equations. Okay, so we've got our table all filled in here. The next question says, graph both the number of apple trees and the number of conifer trees as a function of the number of rows of apple trees. Label your axes. So let's label our axes first. What we're going to do is use the x is going to be our rows of apple trees. So what I'm going to do is I'm going to just go up by, we'll go up by 1. Well, let's go every other one. So 1, 2, 3, 4, 5, and so on. And then the number of trees, it looks like the biggest number here is 40. If we go up by 2s, it'll fit. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This would be 24. This would be 28. This would be 32, 36, and 40. All right, cool. So let's graph these. And what I did is I color coordinated them. I said the number of apple trees will be blue, so I'll grab my blue pen. And so for the first one, it was just 1, so it's going to be somewhere down here. For the second, it was 4, so 2, 4. For the third, it was 9, so right there. For the fourth, it was 16. And for the fifth, it was 25. So right there. So we're going to connect these. And, you know, it doesn't make sense. So here's one thing we need to talk about. This is a finite set of data. And what that means is 1.5 doesn't make sense. You're not going to have 1.5 rows of apple trees. However, I want to connect these just to kind of see the relationship between these dots and to show you that it's not really a straight line. It's kind of a curve. And we'll talk about what that curve is in a second here. So even though all of the points that you graph on here will lie on this curve, not every single point on this curve makes sense because you can't have 4.3 rows of apple trees. Okay, so you do have to be careful there. Let's graph the number of conifer trees in red. So at 1, it's going to be 8. At 2, it's going to be 16. At 3, it's going to be 24. At 4, 32. And at 5, it'll be 40. And these, if you graph them, they do graph a nice straight line. Okay. So we graph them. The blue one is a little curved. The red one is straight. And then there's a few questions to follow here. It says, which row of the table represents a linear relationship between the number of rows of apple trees and the number of trees? And how do you know? So which one of these is linear and which one is not linear? So this one, the number of conifer trees, is linear. And I know that because when I graphed it, it formed a straight line. So if I were answering this, which is linear, I would say the apple trees, I'm sorry, I think I said apple. The conifer trees is linear because it forms a straight line. The other way to know is if you remember we looked at the differences. We'll go back to this page. The differences were all 8. And so you know if something's linear if the first differences are constant. That's how we say that. The first differences are constant. Constant just means they're the same number, so in this case it was 8. Okay, what type of relationship exists between the number of rows of the other type of tree? So now we're looking at the number of apple trees. What kind of relationship is this? And it's a curved relationship, but what type of curve is it? And so this one, we're going to look back at the table, and if you notice, the second differences here went up by 2. And the second differences were constant. They were a constant 2. And what that tells us, if the second differences are constant, is that you're dealing with a quadratic type of equation. So this is a quadratic relationship. And it's quadratic because it's quadratic means like an x squared or an n squared. And that's because the second differences are constant. Okay, and that's it for this question. I hope this helped clarify the apple and conifer tree question.